Hey guys, so I'm gonna go over the last task for the week. Now, for those that did this in the live lesson, you do not have to do this again. This is just like a document for those that weren't in the group lesson. And for those that did do this in the live lesson, or who did do this in the live lesson, this is what you guys did. It's the same thing, so you don't have to watch this video. But for those that didn't attend, in the live lesson, we split into groups of three, and each group wrote down how to solve these problems and wrote their comments in each of these columns. So they were able to get like the insight of other people. For you guys, this is going to be an individual assignment. And what I want you to do for this first triangle is to find the cosine, the sine, and the tangent of angle A. So just this angle here, what is the sine, cosine, and tangent? And remember, sine is S equals O over H. Cosine is our adjacent over hypotenuse. And tangent is our opposite side over our adjacent. So the first thing I would do is label which one's the O, which one's the A, and which one is the H out of these three sides here. And then use that to come up with your fraction, which you can turn into a decimal if you want to. You don't have to do that. You can if you want. Okay. Now, if we go to the second question here, this question is a little different. Okay. They don't tell you the side length, but they do tell you two things that are important. They tell you that the point I is at 9, 12, and they tell you the other 2 points here, 0, 0, and 9, 0. Now, remember that the first coordinate in our two coordinates here is our x, and the second one is our y. So from here to here, if they give us 0, 0, and 9, 0, what is the coordinate that is changing, and how does that tell us the distance from here to here? If you look at these two coordinates here, 9, 12, and 9, 0, what is the difference between the two coordinates? What changed here between these two coordinates? And what does that tell us about the distance on our y-axis from here to here? And then knowing these two things, how would we solve for this third side here? Okay, and if you're having trouble figuring out how to solve for this third side, remember that for any right triangle, we can use the Pythagorean theorem, which is a squared plus b squared, and a and b are just two of the sides. It can be, you can use this side for b and this side for a, it doesn't matter. But then our c squared is always going to be our hypotenuse. And if you take a look, it's similar to what you guys did, I think, in assignment 1 task, or for this week, unit 6, lesson 1. So take a look at that. And then once you solve this, you should figure out the c squared, and our c value is going to be here. So that's our c, okay? And that should give you the side lengths. And then from there, you're doing what you did in this first question here. And you are finding the sine of g, cosine of g, and tangent of g, okay? So you're going to look at this one here. All right. For those that were in the live lesson,